Hello, welcome to Chapter 1, Section 3, Transformations of Linear and Absolute Value Functions. Now in this video, we're really just going to focus on absolute value functions, but knowing how to transform anything is going to be very, very valuable. Now when I say you're transforming things, I mean you're moving things up, down, left, right. You're stretching it, which could be widening it, or lengthening it, or shrinking it, and reflecting, so moving things over the x-axis or over the y-axis. So this is going to be very, very important for you to understand throughout the rest of the year because we transform everything. We're going to transform absolute value functions, rational functions, exponential functions, logarithmic functions, quadratic functions. Everything we encounter this year, you're going to have to transform in some way or another. So the first thing I want to do is talk about the basic rules, okay? If it's a horizontal change, so that means left, right, horizontal stretch, horizontal shrink, something like that, it's going to be inside, and you're going to do the inverse. So this is left, right, and it'll say horizontal, right? It'll say horizontal. So this is also a reflection in the y-axis. Okay, moving left and right, something of that nature. If it's outside, or if it's vertical, it's moving up, down, or a reflection in the x-axis. Okay, or a vertical stretch or shrink, and it'll be very specific. It'll tell you vertical stretch or shrink. So anytime it's vertical, it goes outside of our function, and we do the same. And so here's some examples of all of those things. So first, we're going to write a function whose graph is a translation 5 units up. Well, because it's going up, it's vertical, which means it's going to go outside. Okay, it's going to go outside of our function. And what I mean is that if our function is f, it's going to go outside of it, either before, so right here, or after, so right here. Okay, and then anytime it's a translation, it's actually going to go behind x, okay, in some form or fashion. All right, so that means that it's not the purple part. It's actually the orange one. Okay, and then because it's moving up, it's going to do exactly what you would think. If I want to move something up, I'm going to add 5 to it. I'm going to add a number, so it's going to be plus 5. Now what this means is that f of x is getting a plus 5 at the end. And so you're actually going to take x, the absolute value of x, and you're going to plug it in right there. So this is the same thing as absolute x, or the absolute value of x, plus 5. And that's it. That's the answer. That's all you have to do, is put a plus 5 at the end. Okay, if I'm moving down, 6 units down, that's vertical also. So vertical, which means it goes outside again. Okay, and it's going to go outside of the absolute value of x. So I'm taking f of x, and I'm moving it down 6. So because it's going down, it's going to be minus 6, just like you would expect. Right? When something moves down, you negate it. You subtract stuff from it. Which means that our answer is going to be taking the absolute value of x again and plugging it in there. So it'll be the absolute value of x minus 6. And that's the answer. And that's all, because that's all it said that happened. Now, when we move something left or right, that's horizontal. Okay, so if it's left, it's horizontal, which means inside, and it gets a special I, inverse. Inverse is essentially opposite, but we want to say inverse instead. Okay, now if it goes inside, then we have f, and then an inside. Okay, so the inside is going to be inside the parentheses. Because it's moving to the left, we're going to do the inverse, so the opposite of what you would think. So if it's left, you typically think negative, right, because left is to the negative direction. But because it's inside, we're going to make it a plus. So it's actually x plus 4 because it moved left. So it's doing the opposite of what you'd expect. Now here's where things change a little bit. It's going inside, which means that instead of circling the absolute value of x and plugging the absolute value of x in, we're going to take x plus 4 and plug it inside there. So it's going to be the absolute value of x, okay, with space, and then inside it's going to be x plus 4. Because we're taking x plus 4 and putting it inside. All right, and that's the answer. And that's all. We're going to do the same thing when we're moving to the right. So if it's to the right, we are going to put this to the right. It's horizontal, which means, again, inside, inverse. So we are going to have f of x, and this time, because it's to the right, it's going to be minus, because you would normally think right is positive. So it's going to be x minus 1, which means we're taking x minus 1, and like we did with the x plus 4, plugging it into x. So it'll actually end up being the absolute value, and then the x minus 1 goes inside, so x minus 1. And that's the answer. Okay, so that's for translations. That's moving left, right, up, and down. We also have reflections and stretches and shrinks. So this is going to be a little bit long. Okay. So let's go to reflections. We need to write a function whose graph is a reflection in the x-axis. Well, in the x-axis, if you wrote down what I wrote before, x-axis is actually vertical. And so this change is going to go outside. Now, what you need to know about reflections, so this is important. Reflections get a negative in front. All right, so remember that. A reflection always gets a negative in front of x, so somewhere in front of x. Now, if it's vertical, it goes outside, and if it's horizontal, it goes inside. Well, reflecting about the x-axis is actually a vertical change. So we're going to put the negative on the outside, so it's going to be negative f of x, which means that we're taking the absolute value of x and plugging it in there, so it'll be negative absolute x, and that's the answer. Now when it's in the y-axis, it's going to be horizontal. So that goes inside. Normally I'd say do the inverse, but there's no inverse of a negative, so it's just f of negative x, because that would go inside your parentheses, which means that this time we're taking negative x and plugging it in inside of the absolute value of x, which means we get the absolute value of negative x. Okay, it's different, right? One is outside for A, and the other one is inside. And that's how you do reflections. So let's keep going. Now we have stretches and shrinks. Okay, so a horizontal stretch. Well, that says horizontal. Horizontal is inside, and we do the inverse. Now that means for here, because it's a stretch or shrink, anytime it's a stretch or shrink, and it's inside, so it's horizontal, you have to take this number and flip it. Now, if it's 5, it becomes 1/5. All right, and that's going to go inside. So it's going to look like this. We have f, in parentheses, our transformation, which is a horizontal stretch, which means we flip the 5, so we get 1/5 in front of x. So anytime you have a stretch or a shrink, it goes in front of x, whether that's inside or outside. So just like those reflections. Okay, it'll either be inside in front of x or outside in front of x. And then all we have to do is take this And since it's inside, it goes inside. So it'll be the absolute value of 1/5 x. And that's it. For a horizontal shrink, same idea. Okay, inside, inverse. So we take the 1/3 and we flip it. So that becomes 3. So that'll go inside. So it'll be f of 3x instead of 1/3. Then we take this 3 and we plug it in. So it'll be the absolute value of 3x because it goes inside. And that's the answer. For vertical, it just goes outside. So vertical shrink, outside. Vertical stretch, outside. Okay, because it's vertical. And all we're doing is taking it and putting it in front of f of x, just like we put that negative in part A on example 2 in front of the absolute value of x. So for the vertical shrink by a factor of 1/4 in part C, it'll just be 1/4 f of x, which means it's 1/4, and then f of x is just the absolute value of x. And there we go. Same thing for vertical stretch, right? The stretch. It's just instead of a 1/4, it's a 2. So we have 2 f of x's, right? Because it's a vertical stretch by a factor of 2, which means that the answer is 2 absolute value of x. And that's all. Now, the only time these get slightly complicated is when you have combinations, which means that there's one or more thing that's happening here. So you have to split it up. Okay, so let's read the problem. It says, let the graph of h be a horizontal stretch by a factor of 8, followed by. All right, so that followed by means that we're splitting it up. That means everything before it is step 1, and then everything after it is step 2. And so we're going to go step by step. Okay, so we have a horizontal stretch by a factor of 8. Well, it's horizontal, which means it goes inside. It's a stretch, so it goes in front of x, and then we have to take the 8 and flip it, which means that for step 1, we will have f of 1/8 x, because we had to take the 8 and flip it. It goes inside because it's horizontal, and it goes in front of x because it's a stretch, which means that since the absolute value of x is this, we're taking it and plugging it in, so we get the absolute value of 1/8 x. Step 2 is a translation 10 units down. So because it's 10 units down, down is vertical, so it goes outside. All right, vertical, outside, because it's moving down, it's actually going to go at the end of our function. So for step 2, we take what we already did, so f of 1/8 x, and we move it down 10, so minus 10. Which means that now we're actually taking the 1/8 x and plugging it in there. So it'll be the absolute value of 1/8 x, and then the new part minus 10. And that's what you do. Okay, 2 steps. So instead of just 1, 2. That's all. All right, let's do another one. Write a function whose graph is a horizontal shrink of the graph by a factor of 1/2, followed by, okay, that's the key term. Okay, so that splits this. So we have the horizontal shrink first, and then the second thing is the reflection in the x-axis. So let's do the horizontal shrink first. Well, it's horizontal, so it goes inside, and we do the inverse. So let's look for the number by a factor of 1/2. So that 1/2, that's what we're flipping. Okay, and it's going to go inside. So for step 1, the 1/2 goes inside, but we flip it, so it'll be f of 2x. And that's the absolute value of x, so it's just the absolute value of 2x. Followed by a reflection on the x-axis. Well, x-axis means that it's vertical, so it goes outside. Okay, and remember, a reflection makes it negative. All right, so for part 2, we're going to have the negative version on the outside, of f of 2x. Well, we already know what f of 2x is. It's this right here. So we're going to take that and plug it in there. So it's going to equal the negative version of the absolute value of 2x. And that's it. Okay, so this is the first time we're going to translate stuff. We'll do it again. If you have any questions, make sure you ask during class. Have a good day.